Okay. We have been discussing the big pulse, the triple pulse, and twin verse theory, which we trying to challenge the Big Bang theory. Because the Big Bang theory is saying there was a bang, there was inflation, cosmology theory when the universe first expanded. So that explains the exponential expansion. But to explain the exponential expansion, the big pulse is saying that they were a force pulse, right? That explain the exponential expansion of the universe at the beginning, right? And when that happened, the big pulse is saying a new force and a particle will be created. We explained the photons and the gluon would be created in the same in a similar energy expansion, not in the same energy zone or field. Well, we know that it has to be created in a pretty much pristine field, right? Because of the characteristics. Both of them are massless. They have no charge and have spin 1, right? We spoke about spin, where spin will be created, and we said, the big pulse is saying that the spin will be slammed into the fluctuations of energy field when two energy zones collides, and so will the charges be imprinted on the particles. So the three pulses can be considered as three separate mini universes. Because if the Big Bang is saying with one energy field, and we can create all of these particles, now we have three different energy zones or fields which can create three universes as the Big Bang create one universe. So we can call the three pulses as three mini universes or three mini verses to be, a shorter word, mini verse. So we explain fields, energy fields, energy levels, energy zones, which is similar to the energy fields, and energy bands, where two energy zones will mix together or slam into each other and create a band, right? Because of the mixture around the zones will create a band, right? Real quick, this energy zone here crashes into this other energy zone around here. There's going to be a mixture which will create the energy bands. And of course, the energy bands are going to have different characteristics than the energy zones that was not contaminated. Right? That's the basic principle of that. We spoke about particles being generational, right? Now, in what I'm going to explain in a couple of minutes, you're going to see why these particles are, well, the particles obviously are going to be generational because of this diagram, this, let me try to, what would you call it? This modeling, right? So if we have an energy zone slamming into another energy zone, right? And we have the mixing, right? Mixing. Let's draw the mixing like this. Right? So we have the mixing there. We're going to have different characteristics in this energy band, right? This is the band that we have in the zones, right? As I had explained it before, so if this energy field goes outward, we're going to have certain particles. Even if it's one particle, we are going to have a family of particles, right? Because when it hits the other energy zone, we're going to have different characteristics. And like I said, spin and charge were created when the two energy zones slam into each other, right? And coming this way, we're going to have different characteristics, right? So this way, this way. Now, we have 3 pulses. So if one pulse, right, we have one pulse going this way, and then this is like half of a pulse, right? Because a full cycle of the pulse would actually go from here, which is our starting point, and then it will return back to this starting point, right? And then it goes back out. So we have 3 pulses. Or this can be considered half of a cycle of a pulse, right? A full cycle would be, if we start here, we hit the energy, another energy field, energy zone or field, it will pulse back this way, right? So if we have 2 different particles being created in one cycle, right, or 2 particles being created in half of a cycle, right? We have 3 pulses. We can have six different particles of one particle, meaning you have one particle, but because of the direction and interaction, you're gonna if we have 3 pulses, actually we're gonna have six particles, right? And not only 6 particles, we're also gonna have another 6 antiparticles. So this is what a triple pulse, a triple force theory is explaining, right? And the big pulse. But the big pulse has not happened as yet, right? So we can have 12 particles, right? The quark family has six particles, right? There is the up, down, strange, charm, bottom, and top. So clearly you can see 6 particles will be created according to this modeling. And 12 and 6 other antiparticles. You can do the modeling. It's difficult to really convey that picture. But if we have 3 pulses, we're going in different directions, we're going to have 6 different particles of 6 similar particles, right? And likewise, the leptons, which will be created, remember this is, the quarks are going to be created in the strong nuclear energy zone. And the leptons will be created in the electromagnetic band, right? Which is going to be a different energy field, right? So the electrons have, well, the leptons have six different particles, right? We have electrons, the tau, the muon, and then we have the three more neutrinos, right? Three different neutrinos. So we have six different particles we can call the leptons. And this modeling is the same as a strong nuclear quantum energy field, but this is going to be a band. But the strong nuclear energy field is going to be like a zone. There's a difference, right? So both the modeling is consistent. So there is order before actually there was a Big Bang. But as I said before, the Big Bang is saying there's a big soup. Everything was disordered. And then when the universe cooled down, these particles appear. But the Big Pulse is saying no. We're giving you another idea of how these particles will be created in an orderly fashion. Because certain particles will interact with a certain family of particles, but will not interact, say, with a different family of particles. Right? This is kind of an overview, but it is difficult to do the modeling and to show what's going on. But as we continue to do the modeling, you know, it will get clearer. Now, I had explained non-locality, quantum entanglement, and hidden variables, right? And I had explained, well, we had this discussion that the great man, Einstein, says they must be hidden variables, right? To describe quantum entanglement and non-locality. So Bell came along and he says, well, with some kind of theorem, and it's called Bell's, I believe, inequality theorem, right? Trying to prove Einstein wrong, right? But Einstein is right, because the hidden variables are actually the imprint that we had that discussion before in another video, right? The imprint of the information on these fields. So you can check out those videos. You see, there's going to be a little quantum nugget in every video, but you know, we have to realize, you know, well, it seems so jumbled up, but there's some quantum nugget in the videos. But as we move along, it will be clearer, right? I spoke about causal quantum energy contact, right? So we have causal quantum energy causality, right? We talk about the meson, that a quark and an anti-quark. A quark cannot exist freely. It has to, once you pull it out of the proton, right, it has to connect to an anti-quark. I explained that. why this has to be, why this happens, is because they are created in the same field. So they would have that attraction to each other, right? We spoke about the double slit experiment, right? We spoke about the chaotic, some particles are going to be created when the two bands, when the two zones contact each other, right? The particle or the fluctuations of the energy would actually be chaotic, right? So if a particle is being created in a chaotic energy band, but then as we move along and the energy, I'm running out of marking, as the energy continues, it's going to smooth out. So when we create an electron and we look it through the double slit, we're not realizing that the electron is actually chaotic. It's created in a chaotic field band, right? But as it goes along, it's going to start looking like a particle. And this is how the double slit experiment will be explained. And in the future, you have to look into that. Right? Superdeterminism actually was explained before through the hidden variables and non-locality, quantum entanglement, because what they're saying is, if I were to throw this marker over there, I can determine where it's going to, its action, velocity, energy, and position. But with a particle, in a wave function, they're saying that it's indeterminate because we don't know where the particle is because of Schrödinger's equation and the wave function. We deal with probabilities. We take the probabilities and we try to find where the particle is, right? So this explains this is connected. Superdeterminism is connected to hidden variables from this theory, the big pulse theory, quantum entanglement, right? If you can, because we will know exactly where that particle is, where it was created, the information imprint. So if we want to know everything about particle physics, we cannot just look at what we observe in our universe now, right? We have to go back when there were actual energy fields, energy zones, and energy bands. So I believe I'm going to leave it at that, and we will continue our discussion, right? Thank you. Gotta get some more markers.